Now, building on the concepts from the last module, Administer Virtual Networking, we are now moving on to Administering Intersite Connectivity. In this module, we'll cover essential topics to help you manage and optimize network connectivity between different virtual networks. We'll start by configuring VNet peering, which allows you to connect virtual networks seamlessly. This includes understanding the use of VNet peering, gateway transits, and connectivity needs. You'll also learn how to create VNet peering and determine service chaining uses. Next, we'll delve into configuring virtual network routing and endpoints. This section will guide you through on reviewing system routes and identifying user-defined routes and demonstrating custom routing tables. Additionally, we'll explore the use of service endpoints and private links to enhance your network security and efficiency. By the end of this module, you will have a comprehensive understanding of how to administer intersite connectivity effectively. Let's get started. Now let's start talking about what is virtual network peering and why do we need virtual network peering. Now, so far in the session, we've spoken about VNets and configuring a virtual network, and we've discussed on different settings within, like a subnet or assigning NSGs within a virtual network, or connecting different resources like a virtual machine within a subnet. However, if we have a requirement for moving from one virtual network to another or connecting two virtual networks together, this is something that we can discuss under VNet peering. Now, before I go ahead and explain some of this, let's draw some stuff out on the whiteboard. Now, typically, if I draw a virtual network just like so and suggest this is one of my virtual networks and look at VNets 1 and assume that I have another virtual network, let's call this VNet 2. Now, for me to be able to communicate between the two, there could be many different ways that I could do that. Now, one of the ways in the past, one of the only ways that I could do this would be to create a service within a virtual network called gateway service, and I'll have to enable a VPN gateway, and I'll have to do the same again on the other subnet as well, where I'm trying to link them together. And I'll have to establish a connection between them. Now, that's one way of doing things. However, gateways are not for free and can cost you, because in this case, you'll have to create two different services for gateway services and link these VNets together. Again, apart from that, I could have other solutions that I could use in connecting those virtual networks together, but most of these services are not typically ready for me to use instantly. For instance, my gateway service typically take anywhere between 30 minutes to 45 minutes to get ready for me to be able to use it and start communicating between this resource. However, we can still do this, but today we're talking about a different feature called VNet peering. Now, VNet peering simply allows me to connect two different virtual networks together, and this particular connection gets ready within a few seconds, and I'm ready to send messages across or connect two different virtual networks in my environment. Now, one thing that's important to bear in mind, that as long as my virtual networks live in Azure, doesn't matter where, I am able to pair two VNets together. That means this VNet could be in my subscription, and I could have the second VNet in my subscription, or I could have it in another subscription in my tenant. I could have this in another tenant. I could have this in the same location and as my own virtual network or my first virtual network. Let's assume if this was in UK South and my second VNet or VNet 2 in this case is in East US or any other region for that sake, I can pair these together. However, there is something important to understand in this scenario. If I'm pairing two different regions in my setup, this is going beyond my regional settings of my resource type. So let's assume I have another VNet. Let's create a VNet here and call this VNet 3. And I'm looking to pair the VNet 3 to VNet 1. and I'll create my VNet 3 in UK South. And I'll create one more VNet just up here. And let's call this VNet 4. And pair the VNet 4 to VNet 1 as well. Now let's assume my VNet 4 is now created in UK West, which is another region. Now, typically looking at resources that live in the same region, we refer to these as a regional pair, because we can see a resource that lives in the same region, in this case UK South, from VNet 3 to VNet 1 pairing, they're both in UK South. However, in my scenario, the connectivity between VNet 1 to VNet 2, from UK South to East US, or from UK South to UK West, in this case VNet 1 joining to VNet 4, this is a global pairing, simply because I'm moving out of a single region to another region. So this is something important to bear in mind. So the difference between a regional pair and a global pair. Now I can, like I said, connect any virtual networks in Azure using VNet pairing, regardless of if they're part of my setup or if they're part of another setup, for example, a different tenant, different subscription, different region. Regardless of that, I can pair them together. One thing that's important to understand is once you do VNet pairing, the traffic between the two virtual networks that you are pairing, this traffic is kept on Microsoft Backbone and does not leave your setup or Microsoft Backbone setup and go over the internet. This will remain within Microsoft Backbone setup to ensure that this data is secure between the two networks. Along with that, the traffic between these two virtual networks, let's assume if we highlight VNet 1 and VNet 2 in the setup, and they will pretty much work as if they were part of the same setup. The traffic between the two will flow easily. So a virtual machine that sits in this setup should be able to connect to a virtual machine in this setup without any further configuration or need of me setting any particular detail onto this. So this is pretty seamless connectivity and data transfer between these two resources. Now let's have a look at an example on the slide. Now in this scenario, looking at different VNets that we have, let's break down the slide, this particular scenario very, very quickly to understand what's going on in here. Now, if I look at it, we have a VNet A. So we have one VNet over here. We have another VNet called VNet B. And we have another VNet called Hub. So we have three virtual networks in this particular environment. Now we can see that VNet A is being paired to VNet or Hub VNet, and we have a VNet B that's also paired to the Hub VNet in my environment. Now each of the VNets A and VNets B have a subnet and a virtual machine running inside of them. Same for VNet B or virtual network B. I have a subnet and a virtual machine running inside of that. Now for my hub environment, I can see there are some resources running in here. I also have a subnet which has a resource called virtual network appliance. We'll come back to this in a few moments. And I also have a gateway subnet running in that environment. Now before I go ahead and explain some more details around this setup, let's go ahead and create the setup in our demo environment and learn how to do VNet pairing and understand some important details around that. Right, I'm back in my portal, and what I will do is simply jump onto my virtual networks and take you through some of my existing virtual networks that I took the liberty of creating before this demo started. Now, if I show you very quickly, over here I have my hub network, and also I have a VNet A and VNet B virtual networks available for me to work with. Now, if I take you a little bit deeper into explaining some of this, if I go into VNet A or Virtual Network A, I can check my connected devices like we were doing this in my virtual networking session in module number 5. We have one resource that's occupied this IP or an IP address from this setup. As you can see, we mentioned the very first available IP address is always going to be .4, simply because .0, .1, .2, .3 are reserved. So the very next available IP is .4. So this resource has automatically picked that IP. The next resource we add to this subnet will automatically pick .5 and so on. It'll carry on going to the last address. All right, if I check my subnets here, I have a VNet A subnet 1 available. Again, available IP addresses, in this case is 250, not 251, because one is already been taken by the connected device that I have. Now, I could do the same in terms of showing you my current setup by going into VNet B. I can jump back into my hub and show you some of the details in here as well. However, to do this differently, what we can do, we can utilize a resource type, which is called Network Watcher. Now, let's have a quick look at Network Watcher. Now, Network Watcher is an amazing tool that you can use for troubleshooting and managing your resources in virtual networks in Azure environments. Now, one of the tools that I'm utilizing right now for Network Watcher is called Topologies. Now, within the topologies, all I'm going to do is simply click on my resources and filter down to understand exactly how my current setup looks like. I can see I have quite a few different resources running in my environment. However, for just this part of the session, we'll focus on to some of the virtual networks I've configured, such as my hub, my VNet A, and my VNet B. Now, the amazing thing about the topology within the Network Watcher is I can go into dig deeper into that detail to find out what exactly lives inside of that. So currently I have a subnet. I can filter that further down to understand, hey, what's going on within that particular subnet. Currently, I can see there's one resource called backend server. The backend server has a network interface card. I can see the details. Again, it's interactive. I can go into the settings from here directly. I can see it's got a public IP address. I can see it's got it's got a public IP address. It's got a private IP address. It's got an NSG at the network interface card level. So I can see some of the settings there as part of that setup. Now, this is one of my network that's available for me to look at. And if I go back out, I can bring in other setups, such as I want to see VNet A, I want to see VNet B, and I can ask it to show me some of those details and go into the setup from here to understand exactly what's going on in my environment. So let's bring them out. So let's push them and say add to view. And I should be able to see some of those details on my setup. Now, currently, there is no connection between these VNets. We haven't created the pairing for them. So currently they sit independent. Again, I can explore the same details from one VNet to the other virtual networks that I have, like VNet A currently, and I can go into VNet B and explore the same details in here. So it's easier to visualize for those people who prefer looking at the settings and visualize them, rather than me clicking between multiple menus and suggesting, hey, look, I've got a virtual network under here, subnet under here, and other details. You can sometimes click on the topologies under a Network Watcher to see how it looks like. Now, we'll come back to Network Watcher a bit later. For now, let's go back out of this and jump back into my current setup that I have. So for me to do this, let's go into my virtual networks, and I'm starting off with my hub, and I'm going to start configuring some details in my hub environment. Now, as per the demo slide that we had, we are going to connect our hub to VNet A, or pair them together. All I'm doing is, while I'm in my virtual network hub environment, I am scrolling down the blade looking for a tab called pairing, and I am going to go through creating a virtual network pair right by doing this. Now, while I'm at this menu, let's go and hit add, and let's go and create a connection between these two virtual networks. Now, one of the first things that you're going to be looking at is providing some details to the remote virtual network that you're going to connect to. So in this case, from VNet 1, we are connecting to VNet or VNet A, from hub to VNet A. So in this case, we can call this saying, hey, let's go from hub to VNet A. So that's the name I'm giving to this particular link, so I can refer back to this at a later stage if I need to look at it. Now, how will I make that connection? Currently, I'm going to use Azure Resource Manager to work with it, so I'll leave that option there. And the classic is for the legacy resources. If you don't have any, stay away from the classic resources and leave it with Resource Manager. Now, if you are connecting or peering to virtual networks that are not within your setup and they are beyond subscriptions or in different tenants, it might be worthwhile that you can go and extract a resource ID, which is a unique ID for your virtual network. Simply tick on this box and type in the unique ID for that virtual network that you're trying to peer. Given that you have the right access to that resource, you should be able to connect. In my case, both my virtual networks are in the same subscription, so I'll leave that menu out and I'll simply make sure I'm on that subscription, and we'll go into this and start choosing the virtual network that we are trying to connect. So we're connecting our hub to virtual network A. Now, there are some important settings that we need to configure at this particular point. These are very important to understand. Now, while I'm trying to explain these, I'll try and draw them out to see if they make sense. Now, let's assume we have two VNets that we are configuring our connection to, and let's type in hub on one. And we are going from hub to VNet A. So we're connecting the two together. Now from hub to VNet A, we are connecting. Now this says allow VNet A to access the hub. Now this is suggesting, hey, you're creating a connection between hub to VNet A. Would you want resources, for example, a virtual machine that sits in here, to be able to connect to resources that might live in the hub? Now, you might be creating a pair that is in one direction. That means you only want traffic from hub to go into A. In that case, you might want to take that off. However, typically the use of VNet peering is that you allow connectivity in both directions. So you might want to leave this particular feature on. However, if you do take that off, then it will break that connection for you. So bear that in mind. So I am going to leave that particular feature on. Now, the second part is very interesting over here. Now, this is, if you look or read through this, it says allow VNet A to receive traffic, receive forwarded traffic from the hub. Now, it's not saying receive traffic from the hub, but it suggests forwarded traffic. Now, what is forwarded traffic? In this scenario, if I was to introduce another setup here and suggest I have another VNet called B, and traffic that was coming from VNet B and is landing into the hub, this particular traffic is now, can it be forwarded to this particular setup? That's the second box. It's suggesting, do you want the forwarded traffic, traffic that's not generated inside of the hub, but it's now available in hub because it's come from another virtual network? Can we allow this traffic to move on to A? Now, if I take that box off, this is something that we are initiating a path or chaining of resources to say traffic moving from one VNet to the other VNet. However, by just ticking this box, it will not start bouncing traffic automatically for me. There are certain other settings that we need to go and configure, particularly looking at something called user-defined route that we are looking at a bit later on. So you would need a user-defined route to define the route for this traffic to be routed in the direction that we need it to go. Automatically, it wouldn't. It wouldn't know how to travel. However, by enabling this feature, we are simply saying we might be considering in doing or moving traffic from one VNet to another and then bouncing on to another. So that's the next box that we can tick off. Now, the boxes after that, depending on what your current setup looks like, if, for example, we have resources in our setup, like your gateway services or you're looking at a root server, these are typically an example of a virtual network appliance or NVA in your environment, and there can be many other different types of these. If you're looking at one of those resources, do you want the paired virtual network to be able to utilize its gateway for the paired network, or the other way around? For example, in this case, it says allow gateway or root server from the VNet A. So assuming that gateway is placed over here. So we have a gateway service running in this environment. Now I might be using this VPN gateway to connect to my on-prem setup. I might be using it to connect to another gateway service somewhere else. So if I am connecting to this resource from here to my gateway, do I want to allow my traffic coming in, now in this case, from the hub? So let's assume a resource that sits in the hub. Let's assume a virtual machine that sits here. Do I want to allow the gateway? Reading this through again. So allow gateway and root server in VNet A to forward traffic to hub. So a resource that's connecting from outside somewhere to this gateway, and from this gateway to be forwarded into this hub network. So do I want to allow that? That means basically making the gateway connect to multiple resources in the backend. Now the last setting is typically the other way around of the third option that we discussed, suggesting that, hey, we don't have the gateway in here, but we might have a gateway in this setup over here. So I have a gateway in the hub, and I could say enable the paired, the VNet A resource over here to utilize the gateway that we have in the hub. So for example, in this case, the virtual machine that we created here, let's call this VM1, and we want the VM1 to connect to this gateway and then connect outwards somewhere, maybe to your prem, to other resources using that gateway service. That's what it's suggesting. Enable VNet A to use the hub's remote gateway or root service. So it will send the traffic to the hub, use the gateway, and then send that traffic outwards. So again, typically you'll tick one of these boxes, either option 3 or option 4, depending where your gateway service is, unless you have the gateway in both, but you want to use others. And again, it can become a bit more complex. But in a simple scenario, you'll typically have gateway running into one environment, ideally in the hub, and you would like the other virtual networks that are connected to the hub using that gateway service. Now, in this case, ideally, like I said, we'll plug the last option because the gateway, let's assume, is in my hub. So we won't tick this box off. Now, this is what we are doing to connect the remote connectivity to the resource. So we are in virtual network hub and we're connecting to virtual network A. Now, we're configuring connectivity to the remote connection, which is VNet A. So what we are doing, in sense, is simply looking at creating one leg of this connection. So we are doing one part of this connection for now. Now, typically the VNet pairing, like I said, is two-way connection. So you have the second leg of this connection. So we have the second option is further down here. So the local virtual network summary, and we have the other details further down here. So let me scroll down, but before I do, just make sure this these scribbles will disappear just in a second. So let's have a look at the second part of this session. Now, further down over here, it's asking me for the name for the link again. So what I'm going to do is I am going to copy some of these details as the first part of the link. This time we'll create the link details the other way around. So we are connecting from VNet A. Let me just VNet A to hub. To VNet hub. Right, so that's the connection that we are creating in this second part. So I don't need to come out of the setting and recreate the second connection. While I'm at the setting, I can create both legs of this connection, so back and forth. Again, similar settings, but reverse in this case. So we've just covered them in detail earlier on. This time, remember we had two different virtual networks that we were working with. So we already established the connection between the hub and the VNet A. So we went into connecting from one side to the other. This time is the reverse. Allow the traffic from the hub in this case, to come into the VNet A. So we want that reverse connection coming as well. So we will leave that box ticked. Then the next part is that if the traffic is coming from another virtual network, let's assume virtual network B, and it's landing into A, do we want this traffic to be then forwarded into the hub? And that's the next part, which says receive forwarded traffic from VNet A. However, remember we said by default, it won't automatically start doing transitive traffic. It doesn't automatically happen. You have to define a user-defined route for that. Now, in this case, we'll, again, if you are configuring that, we'll tick this box off. In fact, we'll go and try this. We'll tick these boxes off and we'll try and create this, but we'll have to go and discuss UDR or user-defined routes and see how we create one to make sure this traffic actually bounces off from the resource and jumps onto the other side. And the last part is, again, the gateway part. Am I using the gateway or allowing access from the hub to gateway that I might have in VNet A? Or, like we said, we'll typically put our gateway into the hub part. So this is where we could suggest, hey, allow route server in the hub. So we'll tick this box off down here. In the above setting, we'll probably tick this box. So the opposite settings on both sides. So we'll suggest use other networks gateway. In this case, we're saying, hey, I'm using my gateway. So we can define that depending on which part of the leg or which side of the pair you're configuring. So in this case, because we're configuring this part, so we will suggest, hey, use the hub's gateway service so you can connect outwards. And for now, I'll leave the other one blank. So if that, hopefully that makes sense in terms of connecting or enabling the last two features. Now let's get rid of the scribbles for a minute. So let's go back up in here. I'm going to tick this box off. Let's scroll down and tick this box. So we will allow forwarded traffic for now. Like I said, it doesn't automatically happen, but we'll enable the feature and we'll simply go and hit add. Now, the minute I hit add, like I said, typically when we're configuring connectivity between two different virtual networks, in the past, before we had virtual network peering, this could have taken a little bit of time for us to configure. However, as we talk, this is real time. You can see this is already connected and I can already use it. Literally took us less than 5 seconds or 10 seconds to complete this. So it's very, very quick and it's fully synchronized already for me to utilize this setting as well. Now I am in the hub peering. Let's take a step back out. Let's go into my VNet A and check what's going on with the peering in the VNet A. And as I check this, this is again automatically connected, saying hub to VNet A. And this is the connection that we have already available for us to look at. Fully synchronized, fully connected, ready to go for us to work with. So by just doing one setup, we are actually performing both parts. Now, before we go any further, what we're going to look at is talking about some of the terminologies that I've been using. Now, so far in the session, I've been talking about hub and some of the diagrams that I have. They also have a setup called hub. Now, the terminology is a networking term referred as hub and spoke. Now, hub and spoke is a network topology that we can use. Typically simply means that we have a central part of the setup that we're working on, which we will typically refer as a hub. And all the other connections that we have coming out of this will be what we refer as spokes. Now, if let's assume I have multiple virtual networks, they're all connecting to one central virtual network, and maybe I'm controlling the flow of traffic in this manner. I might have my firewall configured in here in a separate subnet. I might have my gateway configured here in a separate subnet and other resources. Any connection coming from the outside world will hit my hub first based on what type of connection it is. For firewall to then reroute this traffic to a particular service, or for a gateway to then reroute this traffic through a different path that we've created in the back end. So this is something that we refer as hub and spoke. Now, typically, I'm sure you might have heard of hub and spoke in your life before. Ideally, the concept is taken from a bike's wheel. So if you look at me try and draw a wheel, again, my amazing drawing skills at play. So again, that's me trying to draw a wheel. Not sure how amazing that looks, but just to understand the center of that wheel that we look at is typically what we refer as a hub. and any parts that come out of that, these are particularly the spokes that you're looking at. Now, ideally, you don't have to draw your network in a circular diagram in that manner. It can be split in any which way. However, as long as the network traffic passes through a central location and then goes back into other environments, then that is something that we refer as hub and spoke. Hence the terminology that we've been using called hub and spoke. Now let's jump back into the slides for one more time and have a look at the diagram that we started off with. Now we haven't created or completed our hub and spoke setup in our environment. So just for us to complete that setup, what we are going to look at, so far we've completed our connection from VNet A to hub. The second part of this connection would be to create a connection between VNet B to hub VNet. Now I'll create that in the backend really quickly. The process is exactly the same as the connection that we've just created, so save some time in terms of us completing that setup. And we'll then have a look at configuring some more details around this diagram. Now, just to clarify some things over here, let's quickly make some space here so we can see some details. Now, if you look at this setup again, this is a hub and spoke topology. As you can see, we have a hub VNet where traffic coming from outside world might come to any one of these resources, and from here it might be forwarded back to other settings. Now again, hopefully this will help you understand that if I am working within hub and spoke, the options within the VNet peering that we could use for the gateway settings can come very handy in this case, as I might be using that gateway service to move out of my setup or allow traffic coming in from other settings like my on-prem gateway connections or other gateway connections, traffic coming in to my resources. So it could be very useful in configuring some of those details. But for this session, we'll leave them out. Now, one more thing to add to this would be that just bearing in mind, as we spoke in the last module, when you're creating virtual networks, please make sure you plan your IP address as well. This is simply because if you have any virtual networks that are connecting to other networks, if they have overlapping IP addresses, the connection wouldn't work. Again, this is where your planning comes into play. So please plan ahead in terms of using the address ranges that you have in your environment. Now, as part of the setup, we mentioned we can look at service chaining, which means I can look at this particular resource trying to connect onto a resource that lives in a different part of the setup. Now, let's assume we are connecting these two together. Now, let me try and redraw this with a different color so you can see this a bit more clearer. So let's try a blue ink, or in fact, let's try changing the ink to a different color. So we already have red. Let's try orange, just to see if it is more visible. Now, we are trying to do the orange connection here. So we're connecting these two resources together. Now, one might think, well, that's easy. We have two virtual network resources in both of them. Why don't we look at connecting VNet A and pair it to VNet B? And we could do that. And we can pair these together. However, if we did pair them together, currently we are already connected to the hub or paired to the hub. Now this breaks my hub and spoke topology and becomes a complete different topology. We could refer this to as a mesh topology, but we are not going into that. Now we're going to keep our topology as hub and spoke, and we are going to carry on working in that manner. However, when we created the VNet peering, we did allow the forwarded traffic. Just bearing in mind that when we do this, we might need to ensure that we have a virtual network appliance placed within our hub environment, which can be a gateway service, can be a remote server that can help forward this traffic to the resource that we need. Along with that, we'll also need to configure something called UDR, user-defined routes, which we will look at in the next part of this session.